Hello, welcome back. Today I will solve LeetCode 1011, capacity to ship packages within D days. We are given an array of weights, and this represents the weight of different packages. We are also given the number of days to ship all the package to a different port. Our job is to determine the minimum capacity of the ship that can ship all the packages within the number of days that was given to us. Okay, let's do an example. In this array, we have different packages. The first package has a weight of 1 unit, and the second package has a weight of 2 units, and so on. The combined weight of all the packages here is 8. We are given 4 days to ship everything. Suppose that the ship capacity is 1 unit. So on the day 1, we ship the first package. And on day 2, because the capacity of the ship is only 1 and the package weighs 2, so this won't work. We're not allowed to divide the package into 2 and ship them in different days. So let's try a different capacity. Suppose the ship capacity is 3. The first day, it can ship package 1 and package 2 because this has a combined weight of 3. The second day, it will ship the third package, which has a weight of 3. That's perfect. On the third day, it will ship the remaining 2 packages with a combined weight of 2. So it will take 3 days to ship all the packages if the capacity of the ship is 3 units. In this example, we're given 4 days to ship everything, and we just find out that we only need the 3 days, so this will work. Suppose we try another ship capacity. If the ship capacity is 8, which is the sum of all the weights, then we can ship all the package in 1 day. In fact, if the ship capacity is anything higher than 8, we are still not able to do better than the 1 day we needed to ship all the packages. In this question, our goal is to find the minimum ship capacity that will allow us to ship all the packages within the number of days that was given to us. We also understand the minimum ship capacity has to be the maximum value of the weight array, because anything smaller than the maximum value of the weight array, there will be a package that we are not able to ship. Now that we established the minimum capacity of the ship, what is the maximum capacity of the ship that we can try? Well, that will be the sum of all the values in the weight array, because if we use that sum, then all the weights can be shipped in 1 day, and we cannot do better than this. Now that we have the range of capacities, we can either do a linear search and find the capacity that will work within this range, or an even better solution is that we will do a binary search within this range. Again, we are pseudocoding the solution, starting with the binary search template. The low is the maximum of the weights array, and the high is the sum of the weights array. And then we also have the res parameter. That is the response value we're going to return at the end of this function. And we're going to set that to 0. If we cannot find a capacity that can work, then we'll return this value. So again, we'll start with while low less than equals to high. We're going to determine the mid value, and we're going to pass this mid value and the weight array, and also the number of days that's given to us into this function called can ship in days. And if this does work, then we will set the res to the mid value because we have find a ship capacity that will work. And then we're going to set the high value to mid -1 because we want to see if we can find a capacity that is lower, because we want to find a minimum capacity that we can ship all the packages. However, if the mid capacity does not work, then we will set the low value as mid +1. We're going to search in the upper half of the range. And at the end, we will return the response parameter. Let's talk also a little bit about this can ship in days function. This function will take in the weight array, the capacity, which is the mid value for every iteration in the binary search, and the number of days that's given to us. So we have a parameters called needs days, and we set that as 1. Need days is the parameter in which we're going to compute the number of days we will need to ship all the packages given this capacity. We also have another parameter called sum, and this will be the accumulation of weights of the packages, and we will set this value to be 0. With a for loop, we'll go through all the packages, and we're going to add the weight of each package to the sum parameter. And if the sum has exceeded the capacity, then we increment the need state parameter by 1. Furthermore, we will assign the sum value to be the weight of the current package, because this package needs to be shipped in the next day. If the need days that we just computed has exceeded the days that we allow, then we know this is not going to work, so we're going to return false. Otherwise, we'll return true. Let's go through this quickly with an example. For example, in this weights array, we have 1, 2, 2, 2, and the ship capacity is 3. We start with need days equals to 1, and the first iteration of the for each loop, the sum is 1. In the second iteration, the sum is 3 because we added 2 here. And then in the third iteration, the sum is equals to 5. Now here, you will trip the if statement, because now the sum is greater than the ship capacity. We will increment the need days parameter. So need days becomes 2, and then now the sum is 2 because we are at this iteration. And then in the final iteration, the sum is now 4. And then again, this will trip the if statement, and then we'll increment the need state value by 1. So now the need state is 3. And then this will finish the for each loop. So the total number of days we need is 3. Okay, now that we talk about the pseudocode, we just quickly convert this to real code. This C# implementation is available in the GitHub links below. In that GitHub link, I have also included the Python version of this code. Everything here is same as the pseudocode. So this is very straightforward. And we can go ahead and test this, see if it works. And it looks good. Next time, we'll do another binary search problem. Hope to see you then.